All right, welcome back, everybody. I'm going to do KH. Okay, awesome. I have no idea if any of those are going to show up. But there's one derivative rule, and I don't know for whatever reason, there's one rule that I just don't remember. And we're going to see it today. It's the single rule that I always have to double think and triple think about. We're still in 3.1, just for the record. We're still doing chain stuff. And we're going to start talking today with a little recall here in a moment. But we're going to talk about our exponential functions. Now, there's one of them that's super duper nice, and we wrote it yesterday. I jumped the gun a little bit because we know the derivative of e to the x. It's nice, it's e to the x. Or we know the derivative of e to the u. It's nice, it's e to the u, u prime. Now, as we go through our exponential functions, what we need to concern ourselves with is numbers that aren't as special as those discovered by Leonhard Euler. That's the number e. It's special. There's a lot of special stuff about it. Now, specifically for our exponential functions, what we're really focusing on is a to the x, where we'll just require a couple things. We'll make sure that a is not equal to 1, because that's a boring function if it is. Then we'll also require that a is greater than 0. Okay. A to the x and e to the x are different. E is Euler's number that shows up all over the place. And we're going to do a quick recall real quick. That was redundant, but that's okay. I want you guys to help me simplify the following, or tell me how can I simplify this. And it's ugly. We've seen things like this before. We're going to try to put the pieces together fairly quick. What if I did e to the power of the natural log of a to the x? It's ugly, I think. In my opinion, this is kind of an ugly expression. Now, there's one huge thing that we have, and whether you recall it off the top of your head or not, we're about to. Is there a relationship between e and the natural log? So it's logarithm. The natural log is log base e. So I like that, love that actually. But Rafa, go ahead a little bit further, or anybody go a little bit further. What if it's not just e and natural log? What's the relationship between an exponential, a to the x, and log base a of x? They relate to each other in a really important way. One more time. They're opposites. There's another more formal word for that, but I agree with that. They're opposites, meaning they undo each other, maybe is how you could word it. There's a way to talk very specifically with like really specific math language, though. They're inverses of each other. Now, what that means in this context is if I have e to its inverse and these undo each other, what is left? If the e and the natural log undo each other, and it's like they cancel out and everything just falls down due to gravity, what are we left with? I'm pretty sure I saw you say it. I didn't hear it, though, and I'm not the best lip reader. A to the x. Everything else falls out, right? They just undo. All we're left with is the argument. Now, this is indeed a to the power of x. Now, it's weird to do this in 2 different steps, but there's another way that we could have done this. And we're going to just dig deep here. There's a way that we can move exponents with logs. Now, before you write this, I'm just going to throw up a couple examples here. For example, natural log of x squared. That 2 can move when we rewrite it. Anybody recall where it moves? To the front. And if you have trouble remembering that, that's okay. Do you guys agree that this is just natural log of x times x? And since I know that natural logs and exponentials are pretty similar, if you have a to the x times a to the y, what happens? A to the x times, and we're like tying a bunch of different pieces together here, trying to do it really quickly. What do these exponents do? They don't cancel. They add. Now, if we did this, it means that since they add with exponentials like this, that similar property must be represented here somewhere. Multiplication turns to addition. Multiplication turns to addition. It's the same thing. If we wanted to expand, We could say this is a natural log of x plus a natural log of x, but that's a silly way to write repeated addition. What's a better way to write this? 2 ln x. And this is the property. This is where it comes from, and we're going to use that to our advantage. If we look at this one very specifically, we could rewrite it, and it feels weird because I wanted to take that trip to a to the x first. But I think that we could probably rewrite this as e to the power of x natural log of a. Do you guys agree with that statement? It's just that same power rule, right? I just moved it up front. Nothing too crazy has happened. Now, all of a sudden, it gives us a way to get into our derivative rule. Everything that's in this orange color, you can write it. Nothing's going to be wrong, but it just really depends on how specific you want your notes to be. If we looked at this, and now I wanted to take the derivative of this, let's think about it. So we're going to now build up and derive a formula. Notice, we are going to derive a formula for differentiation. We're not deriving the derivative. We're making a formula. We're finding where it comes from. So check this out. I want us to take the derivative of this. d dx, and again, orange is optional. I'll switch back when we get to our final conclusion, but everybody will benefit from doing a little bit of this. Let's try to take this derivative. And we now have a rule that works for this. I see e to some expression. I'm not going to just think it's e to the x. It's like an e to the u. And I'm really pointing that out because yesterday we focused on things that had u in them. And specifically, we have an inside and an outside. I have to use which rule? So I have to use the chain rule. So I have e to the u up on the board. How do you differentiate e to the power of u? Or anything with a chain rule. What's outside and inside? And it's weird because it doesn't look like it on this one. Outside is e to the u, and the inside is u, right? The x ln a. So what's the derivative of e to the u? E to the u, there's one piece missing there. Times u prime. Now, this part is hard to see. In this situation, a is a number, right? If I wanted it to be a nice number, and it could happen, it probably won't realistically. But if I said e to the 2x instead, what's the derivative of 2x? 2. This one sounds uglier. What's the derivative of ln a, some ugly number, x? So not a ln. Do you guys, and we'll see it really quickly, and it'll be clear. It just feels weird to write. 2 to the x, when we differentiate, becomes, whoa, nope. Sorry. 2x, when we differentiate, it becomes 2. What if I gave you pi x? It's a pi. Now, it doesn't really matter what number I write here. Do you agree with that? And this is the natural way that we write it, but is that still a number, just times x? So what's its derivative? It's just natural log of a, right? It's the same thing. It's just a constant multiple. It just looks ugly. So when we do this, here's e to the u times u prime, and you guys just told me that the derivative of u in this case was what? Natural log of a. And we're getting close. We're almost done. In fact, we're one step away. If you haven't written down anything yet, I'm going to go ahead and put a star here, and we're going to put our last little equals. And it's wonky that I did it this way. Sorry about the organization. Well, e to the x ln a, I'm going to do a little bit more scratch work if you'd like. That's e to the x times e to the ln a. Is that still true? They multiply, right? Ooh, is this true? I'm wrong. Scratch that. That's not true. I lied right to your faces. OK, as we're looking at this, maybe we can go without going quite as in hardcore with it. If I have an e and an ln, any part of this fall out? The natural log and the e, like they interact with one another, right? So as we are seeing this, what we're going to ultimately conclude at is we're simply left with a, because e to the ln a, that is just a, to what power is still left up top? If we take out the ln a part, and it just moves out front because e and natural log undo each other, I think we just have an x up top, right? Ooh, y minus 1. So you're trying to use power rule stuff? No power rule here. Like, we've already done the derivative. We're just cleaning it up now. Like, if that's not clear, this right now is the derivative. We're just making it look nicer. So very specifically, what we're going to see is we're going to have ln a, e to the ln a leaves an a to the x, because our natural log has disappeared, it's fallen out, times the natural log of a. Now, this rule, for whatever reason, does not stick in my head. And to make it like really clear, because I think that this could be misleading, what we have just worked out as a more than just that part, we're going to write it in its more general form. If we want to take the derivative d dx of any number a to the power of u, we can use this same technique to get there. First off, that's similar to what we started, and we could do this manipulation every single time. I don't think we should. I think we should just get a shortcut and be done with it. So here it is. We notice that a to the x is what we took the derivative of. It showed up again, right? So if a to the u is what we're taking the derivative of, it's going to show up again. A to the u times the natural log of a. And there's one more little piece. I didn't show it, but did I multiply by 1 here? Could I? I could. Where would that show up in this rule now that we have e to the u? We are chaining. Louder? It's u prime. This derivative, for whatever reason, is the single one that just does not stick in my head. Year after year, no matter how many times, I just can't remember it. Very similar to something else we'll see later in the year. This one, I think everybody in here will be able to remember this better than me. Cool. All right, so let's do it. Let's knock out a couple examples. We have a pretty chill class, and then we will have some time for homework, I think. Or I won't give you homework, one of those two things. So let's check it out. I want us to differentiate, and all I'm going to say is d dx. Now, just to be ultra clear, when you see d dx, I just told you, but what am I asking you to do if this is all the instruction I'm giving? Find the derivative with respect to x. Okay, so here we go. On our first one, let's see if maybe this is the year that it finally clicks for Earl Holloway. F of x is 2 to the x. All we need is f prime. And what's really convenient about this is that, well, I have the formula immediately written above it. Is this form, 2 to the u? And coincidentally, this one's going to be nice because what's the derivative of u if we needed it? It's 1, so it's pretty chill to deal with on this first one. So let's just plug and chug. If I want to take this derivative, f prime of x equals that first term. I'm just going to keep it, which means I'm going to have a what written first? 2 to the x. Then I'm going to multiply this by the natural log of what number? 2. And then I'm going to multiply this by the derivative of what? U. And what is u in this particular problem? It's x. And what's the derivative of x? 1. I would never really truly encourage you to write times 1 here, but I think it's nice to see it with the chain rule stuff. It's an ugly rule, but does it feel all right? I guess we'll see. Another one together? Do you guys want to try one on your own? I'm going to give you a harder one. Okay, for this one, I want you guys to do f of x equals 3 to the negative x. Cool. And then once you get an answer for b, if you want to look up, I'm going to have another one, f of, I have to use x, equals 2 to the x squared. I want you to find me f prime on both Bravo and Charlie here, and we'll come back together in just a moment. Can't tell you a reason they are ugly for me. Like, there's not much in calc that's ugly. This is the ugliest thing in my, like, all year. This is going to be the ugliest thing for me. Don't know why. But as long as you can recognize what the base is, a, and what your variable or u, your power is, we're golden. F prime of x. In this situation, we don't touch a to the u first. We just simply rewrite it. 3 to the negative x. And then I multiply it by the natural log of what number? 3. And then last little step, and I'm going to do this in a one-step process instead. I need to write the derivative of what? So what is the derivative of negative x? Okay, you're likely going to have it written right here. That's okay. I'm going to undo that real quick because if this is going to happen and you can see it's coming, I don't think we really need that. I think I can just multiply it by -1 right here. And I would just call this -3 natural log of like blah, 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 blah. Okay. If you have -1 here, you don't have to erase it. I was trying to save some time, but it's really just this. And now we can see very clearly what happened. Cool. This one, it looks grosser. Anybody have an idea of what 2 to the x to the 2 looks like? I guarantee it gets big fast. But I don't know either, and that's okay. We don't need to know to be able to find the derivative. F prime of x. First thing I'm going to do is rewrite it, yeah, without anything. So 2 to the x squared. Got it. I'm then going to multiply it by the natural log of something, natural log of 2, and then I'm going to multiply it one more time by the derivative of something. It's going to be derivative of x squared, which is 2x. Now, I would probably rewrite this. And there's a natural way that one could write this. Cool. I'm going to give you 60 seconds. You get the second part of our lovely Friday. I want to know something good in your lives this week. Could be school related, doesn't have to be. But we'll go 60 seconds and then we'll share there too. All right, here's the deal. We are going to do one more problem together. Monday, you're going to come prepared to work. All right, so, right, that's the song. It took a second to connect. Okay, so we're going to do 2 things here. We will work out the general power rule. I guess we'll do it right now. And I wanted to do the really neat problems, but I guess we'll save those for Monday. So Monday will be like 5 to 15 minutes of example problems and a little tiny bit of lecture, followed by the rest of the time to work on stuff. Because to be good at this, it just takes practice. And I think you have enough time in the day to practice, but we have time here where if you're not doing it perfectly, then we can clean it up in class together, and I'm cool with that. So we're going to give ourselves one more little section here where we're going to talk about the general power rule. Now, we've seen the power rule already, and it's just x to the n minus 1. We are going to make it more generalized, the general power rule. Okay, for our general power rule, all that we're going to change, and this is going to be super concise to write, and super short section because it's literally just this definition and then a problem or 2, and that'll put us about at the end of the hour. If we want to find the derivative, d dx, so the derivative with respect to x, of a generalized power rule, and all that we've already done it, to be honest, I'm going to use a set of parentheses and say we have a function u of x to the power of n. Now, we've already done these problems. We just haven't written out the true generalized rule. What you'll notice, or if you haven't, you will when I point it out, if you go back to whenever we defined the power rule for the very first time in the middle of chapter 2 or the second section, we wrote this rule. We're writing the exact same rule just now with the chain connected to it. So if I wanted to differentiate this thing, what is the inside and what is the outside? U of x is the inside, and the outside? So I like x to the n. I would even accept u to the n, something more than just n, because I know where you're saying n, because it's obviously the power, but make sure you have to the power or something of that so we have it. Okay, so the normal power rule, what happens with this n? So it goes to the front, n, and then we multiply it, and I'm going to use parentheses. What do we do with the inside now that we're chain ruling? Nothing. Don't do the derivative yet. That's a mistake that people make. So we just get n times u of x to what power now? To the n minus 1. And we will simply multiply this now by what? U prime of x. Now, we've already done problems like this. We haven't seen them yet super detailed, but let's knock one out real quick. So we'll see if we can. We got 90 seconds. Let's do an example where I'm not going to name it because it's obvious that we're doing this. And we're just going to do one right now. I want us to find the derivative with respect to x. So we'll say d dx. And I want the derivative of x squared sine of e to the x. Okay. So check this out. We have a little bit more complicated of a problem at this point. First thing, forget about the chain rule part. What rule do we need to find the derivative of x squared times sine? We need a product rule. Okay, so there might be a chain involved, but we'll do the product rule first. So help me out. First times the derivative of the second plus the second times the derivative of the first. Okay, what's the first? X squared. And now we need to take this times the derivative of the second. Now, when I look at the second, it can be sneaky, but with the argument I think it's a little bit more clear. This is my second. So we need the derivative of that. What's the derivative of sine? Cosine. And what's the argument of this cosine? And then that was the inside, right? Now we multiply by what? So pause. You're right, but you're missing a part. If I just said what's the derivative of sine e to the x, it's cosine of e to the x times we have to do the derivative of the inside, right? There's a chain happening here. So the one little part that we missed, what's the derivative of e to the x? So here's first times the derivative of the second plus the second, and we're going to finish this real quick. If you're 30 seconds late, have your teacher email me. Second is sine of e to the x times the derivative of the first, which is what? 2x. We will continue simplifying. There's no homework this weekend. Later, Raiders.